So, in the DS algorithm, the main block where encryption happens with a hidden key is the S box. S box is a substitution box which introduces nonlinearity in the system. The input and key are XORed and given to the S box to find out the output. The power source is where we get the power to the S box, and we get the data from our power source. We created a 7-bit input and a 7-bit output S box from the Casimir algorithm, and the respective output for sequential input is shown. Our workflow includes system identification and implementation, performing a DPA attack, seeking counter logics, and finally obtaining a DPA resistant system. Our ongoing and future work is shown there. The system implementation has been done in Cadence. We have a 7-bit input along with the 7-bit key XORed together and given to the S box. The outputs obtained is a 7-bit one, and we'll be taking current traces from the power supply, which is shown in red color. The internal hardware of S box, as one can see on the screen, is represented as a Cadence schematic, and one such output from the S box, Y0, is enlarged view. The entire design is organized with a 180 nanometer CMOS based system implementation. The internal structure of the AND gate and XOR gate required in the S box are shown in the figure. The first step in the DPA attack involves calculation of the Hamming distance based on the number of bits changed for the respective transition. The original power trace is also shown, along with the current values and power traces assumed with the time axis, shown in the dotted yellow lines. The output transitions and power traces entirely are shown in the figure, and the power traces of one such output, Y6, is shown in the figure enlarged view. Once we get the power traces, we need to sample the curve, and here we have sampled it into 1000 values. As we can see, current values, single power trace, and along the time axis, we formed a matrix of dimensions number of transitions into 1000. Now, as mentioned earlier, the last step involves finding out the Hamming distance matrix. The Hamming distance matrix corresponding to a single key was shown, and in the same way, we have to iterate the key values for all the possible keys with 7 bits input.